Um, hi class. So our subject is transmission media and antenna system. This is our module 1 and we will talk about radio waves. So let's go for the basics ng radio waves. So radio waves are used for wireless transmissions of sound messages or information for communication, as well as for maritime and aircraft navigations. What else ginagamit si radio waves sa many applications? These applications includes yung sa TV or the television, the AM and FM radio for military communications and air traffic control, cell phone and wireless internet. So how do they work? So radio waves are generated by transmitter and then detected by a receiver. So a radio transmitter is electric circuit applies electric current to an antenna to generate radio waves. So the antenna then radiate the radio waves. So yeah, so as you can see, meron silang wavelengths that very long compared to different types of electromagnetic waves like infrared or gamma. So kung nakikita nyo naman dito, ito yung radio waves, the next is the micro, the infrared, visible light, the ultraviolet, X-ray, and gamma. So they are the longest types of electromagnetic waves and travel at the speed of light. So ito yung pinag-usapan natin. Okay, so ulitin ko lang ulit ha. Itong electromagnetic energy travels in the form of waves that have a broad range of frequency called the electromagnetic spectrum. Yan. Yung kabuuan yan, yung electromagnetic spectrum. So dito, pinapakita lang din natin na merong different types of electromagnetic radiation. So yung frequency of a wave gives in hertz. Okay, so I guess everybody knows. Yan, hertz. So ito tinatawag na number of cycles per second, meaning that 1 hertz corresponds to 1 cycle per second. So katulad ng sinabi natin kanina, okay, ang radio waves, nag-work siya pag merong transmitter and receiver. So radio waves were discovered over 100 years ago and until now, they are almost taken for granted. It's because the radio waves do not only provide us with radio signal frequency, but they also carry signals that our televisions and mobile phones can use. Additionally, yung mga transmission ngayon, therefore involves not a single frequency electromagnetic wave, but rather a frequency band with proportional into the information density. So the width is about, okay, 10,000 hertz for telephone and 20,000 hertz for high fidelity sound and 5 megahertz or 1 million hertz for high definition television. So this width And the decrease in efficiency of generating electromagnetic waves with decreasing frequency sets a lower frequency limit for radio waves near 10,000 hertz. Yan. So, kung babasahin niyo ito ngayon, okay? What radio waves do? Radio waves transmit different sort of information. Pwede siyang music, pictures, or conversation. This is invisible data and is contained in a radio wave. So, if radio wave did not exist, it would be impossible to transmit and receive information as easily, if at all. So, lahat ng radio waves ay naging useful and tumaas and nag-evolve to a wireless technologies. So, television and mobile phones are just a couple of things na ginagamit ng radio waves. Other things that radio waves transmit signals for are the wireless networks, GPS receivers, wireless clocks, and even small things like garage doors openers. So, kung nakikita nyo din dito, there's a basic radio wave structure. So, radio waves all have the same basic structures with the wavelength. So, kung makikita nyo, pag pinag-usapan natin si wavelength, it means yung travel distance niya from one point, this point to another. And then the amplitude. So, tingnan natin, radio waves all have the same basic structures with wavelengths and amplitude being the only thing that can change if and when a radio wave is modulated in some way. This could be the sound or other data. So, the radio waves diagram, napakita lang dito, is unmodulated radio wave structure. So, all unmodulated waves looks the same. So, meron tayong different wave structures. Meron tayong amplitude modulation. Okay? So, pag pinagsabi natin amplitude modulation, is a process by which the wave signal is transmitted by modulating the amplitude signal. So, mas madalas siyang tinatawag na AM. So, it is often called AM and is commonly used in transmitting a piece of information through a radio wave carrier. And syempre, dito rin papasok yung FM. So, the difference is how the carrier wave is modulated or altered. So, sa AM radio, the amplitude or overall strength of the signal is varied to incorporate the sound information. With FM naman, the frequency of the carrier signal is varied. So, kung titignan nyo dito, yung difference ng AM and FM. So, in real life, si amplitude modulation is ginagamit siya for audio broadcasting in long and medium wave bands, as well as for two-way radio communication via aircraft high frequency. Okay, ginagamit siya. Next, ganito naman tayo sa FM. Nakita nyo ng AM and then yung FM. So, the radio wave above or itong nasa gilid nyo is an FM radio wave. When sound is added to an FM radio wave, the wavelength changing giving the wave a more varied wave structure. However, the amplitude of the wave stays the same. So, minsan tinatanong din natin na why FM modulation or is better than AM. So, the power of the transmitted signal is proportional to the amplitude of the unmodulated carrier wave, and it is constant. So, CFM is usually more power efficient than the system. So, ulitin lang natin to understand you more. Okay. Pag si FM stands for frequency modulation, has a better sound quality due to higher bandwidth. Okay, higher bandwidth. And then also, the way the audio is encoded for the FM make it less sensitive to the interference from electrical activity from storms or electrical devices than FM. Why? Kita na lang din natin dito. Okay, so example, ito yung land nyo. And nandito si tower. Yan. So si FM nagtatransmit ng higher bandwidth. So higher bandwidth. So sinasabi din dito is less sensitive siya from the electrical activity from storms or other electrical devices. So maglagay ka ng, let's say, clouds here. Yan. So hindi siya din masyado naapektuhan kay FM. But kay AM naman, okay, sinasabi natin kanina for longer. So, hindi siya higher kay FM. So, sa baba lang siya dumadaan. Okay, ito si FM. And nandito si AM. Pero minsan nagkakaroon ng interference. Okay, kay AM. Pag meron ng mga mountains or any pwedeng makapag-stop ng signal kay AM na mga electrical devices. Okay? Sample naman dito. Yan, yung mountain. Yan hindi magana masyado si AM. Pero pag si FM, ayan, sample pag mayroong mga building na nakaharang or walang masyadong nakaharang, mas malakas yung signal nito dahil sa taas dumadaan si FM. Ano lang naman. So, again, dagdagan din natin, no? Kay amplitude modulation, pinaka-advantage siya is affordable, easy to detect even in weak signals, narrow bandwidth, and broader coverage. Kaya minsan pag pumunta sa mga probinsya, mas madalas na receive si AM. Pag frequency modulation naman, okay, si FM, better sound quality and less power consumption. Ayun yung nangyayari. Yung pinaka-advantages nila. So, bago pala yun, no? I-add din natin i-add ko na, there are 4 types of radio wave propagation. Galing ko magsulat. Okay. 4 types ng wave propagation. So, radio waves can propagate from the transmitter to receiver in 4 ways. Meron tayong ground, meron tayong sky, free space, and open field waves. So, yung ground wave exists only for vertical polarization produced by a vertical antenna when transmitting and receiving antennas are close to the surface of the Earth. So, si ground wave propagation is dominant only at relatively low frequencies, up to a few megahertz. So, it need not concern masyado. Skywave propagation is dependent on reflection from the ionosphere. Okay, so nagre-reflect. Lagay nga natin. Ground wave, and then skywave, nagre-reflect siya from the ionosphere. A region of rarefied air high above the Earth's surface that is ionized by sunlight. And we will be discussed further. So the ionosphere is responsible for long distance communication in high frequency band between 3 to 30 megahertz and is very dependent on the time of day season. So longitude on the Earth and the multi-layer cyclic production of sunspots on the sun. So in general, skywave propagation does not affect the short-range radio application. So the most important propagation mechanism for short-range communication on the VHF and UHF band is that which occurs in an open field where the received signal is vector sum of the direct line of sight signal and signal from the same source is reflected off the Earth. So radio waves in television. So radio waves in televisions are like FM radio waves and not AM radio waves. Television stations do not switch off overnight. They play constantly, giving us programs to watch through the both the day and night. So for 3D broadcast are encoded with frequency modulation and pictures are encoded with amplitude modulation. So yun yung tatandaan nyo. So yun natin. In broadcasting, yung sounds encoded siya for the frequency modulation and yung pictures are encoded with amplitude modulation. So television stations use radio waves to broadcast their signals through the air, just as broadcast radio stations do. Yung mga TV band for channels 2 to 6 is next to the FM radio band. So, kung meron kayong radio and i-tune yung FM radio nyo below 88 megahertz, you would pick up and hear the audio transmission from channel 6. Example lang naman. So, again, dagdag-dagdag natin. Television waves specifically have range of wavelengths bit around 50 centimeters to 10 meters length. Radio waves overall have a huge range of possible wavelengths ranging from 30 centimeters to 500 meters. Radio waves in mobile phone. So as you can see, we always have mobile phone na ginagamit. Radio waves are extremely important in the makeup of mobile phone. So a mobile phone would not work if radio waves did not exist. So when people use their mobile phones to ring for a conversation for their is a transmission takes the sounds of your voice and encodes it onto something known as continuous wave. And yun din, yung radio frequency waves or electromagnetic fields and siya katulad ng ionizing radiation such as X-rays or gamma rays and can neither break chemical bonds nor cause ionization in the human body. So, ang ginagamit na um, bands, okay, for cellular phones is radio waves have frequencies as high as 300 gigahertz to as low as 30 hertz. So, typical frequency range for the cellular phones is 900 megahertz to 1,800 megahertz, which comes into the ultra high frequency. So, lastly, mobile phones can lose signal when the radio waves are interrupted. So this is especially noticeable when traveling in a car or on a train, when tunnels distort the signal and conversation can be cut off. This is the end of Module 1.